Good morning all. Today we are going to see about industrial sensors for automation. Myself, R. Vinod Kumar, Assistant Professor, Electronic Instrumentation Department, Hindustan College of Engineering and Technology. So the contents of this lecture is introduction, temperature sensors, pressure sensors, Mem sensors and torque sensor. So what is a sensor? So sensor is a device. So it analyzes the physical data and this physical data is converted into the electrical signal by using a transducer. So it acts as an input device. So it requires a voltage source, it requires a ground and also it will give the output. So whatever the physical data we need to measure, that will be sensed through this particular sensor. So the temperature sensors, pressure sensors, Mem sensor and torque sensor are the important sensors used in automation. So these four sensors play a major role in the automation industry. So first we are going to discuss about the temperature sensor. So temperature sensor, as it is clear from the name itself, it senses the temperature, and of course we need to interrupt this temperature and we need to use it as a parameter for different purposes. So for that we are going to use the temperature sensor. So digital temperature sensor and humidity sensor are also available for the automation industries. In digital temperature sensor, so the digital temperature sensor is mainly silicon based temperature sensor, and it is mainly integrated circuit based, IC based, and it provides the accurate measurement. That is one type of advantage. And it uses sophisticated A to D converter technology so that we can able to get a precise reading. Platinum and nickel sensor are both resistant temperature detectors that are mainly used in this digital temperature sensor model. And platinum can withstand extreme temperatures, that is minus 200 degrees Celsius to up to 1000 degrees Celsius, whereas nickel has higher resolution. So within a small temperature range it has a higher resolution, so we can get minor variations also can also be measured using this digital temperature sensor. So in this picture you can able to see the nickel type of sensor and also the platinum, where you can able to see the platinum coating at the end point. Okay, so this is an IC based, and you'll be having a voltage source, ground, and also the output. Humidity and temperature sensors are mainly used in potentially explosive areas. Okay, so where the higher temperatures will be there, and where the stability will be in always we try to go to the non-linearity condition. So that we need to measure the temperature. So for example, in boilers, in thermal power plants, and in any processes where the temperature needs to be monitored and controlled, there the temperature sensor should be used. And in the two-piece version, of course, you can increase the temperature from 125 degrees Celsius to 200 degrees Celsius, and of course the 200 degrees Celsius, if you are speaking in terms of pressure, it will be 25 bars. And this picture represents the humidity and temperature sensor which is used in the industries, and there are different models available, and different companies are providing such type of temperature sensor, but the overall representation will be like this. And applications of temperature sensor is they are should be weatherproof, and the continuous measurement of temperature should be there in material of the temperature, soil, whatsoever. So in all the parameters, the temperature should be sensed, and it should have an accuracy and stability, and also used to be in complex industrial applications, and also in rough operating conditions. So next is a pressure sensor. This is the second important sensor. So it will gather the information related to the pressure changes, and that will be converted in directly to the electrical signal. Okay. So vacuum pressure sensors will measure the pressure below the atmospheric pressure level, where the pressure will be very minimum to that of the null pressure to that of the negative pressures. You can use the vacuum pressure sensor, and it will be based on the heated wire with electrical resistance correlating to the temperature. So this electrical change in the electrical resistance will be proportional, and based upon the proportionality we can able to calibrate, and also the effective measurement of the vacuum sensors can be increased for longer period. Okay, so this will be the representation of this vacuum sensor, and you can able to see the digital pressure gauge available, where it will show uh, the pressure, and then the sensor where the signals are converted to that current loop of 4 to 20 milliamperes. So based upon the variations from 4 to 20 milliamperes, you can able to sense what is the pressure variations at that particular point. Then applications you used to measure the pressure, that is of course it will be used for measuring the vacuum pressure, and also in weather instrumentation, aircrafts, okay, because while we are using the airplanes and all, the atmospheric pressure needs to be checked, and the internal pressure in the aircraft also should be maintained, and also in the vehicles and machineries where the pressure should be in controlled state. And also you can able to measure the flow, speed, water level, and altitude. As the altitude increase, we can able to see that the pressure also will be in increasing order, and the increase in water level also will show some variations in the pressure. So that also you need to see. Okay. Next is the Mem sensor. So Mem sensor is nothing but the micro electromechanical systems. So this is nothing but it is a tiny integrated device or system that combine mechanical and electrical components. So it is a combination of both the mechanical and the electrical components. So of course it is an advanced the type of sensors. Okay, so it will convert the mechanical signals into the electrical signals. So the acceleration, motion, MEMS are the important sensor used in the industrial automation. So the force will be applied to the moving structure of the sensor, and when the force hits the structure, it will be deflected. So this deflected will be measured by the electrical or optical techniques. Okay, so either this deflection will be measured by a resistance, or this deflection can be viewed by using an optical source. The changes in the optical source before hitting the surface and then after receiving the particular vibrations. Okay, so and then it will be able to calculate the applied external force. So it's acceleration and motion MEMS used for that. So it's one of the main inertial sensors and also dynamic sensors, because dynamic operation only it will be used for the acceleration and motion type of applications. Okay, and the main thing is vibrating damping, vibration measurement, transport monitoring, compensating vibrating at low stress, preventive maintenance, and maximum vibration monitoring of wind turbines. So of course in wind turbines also such type of MEMS acceleration. So what is the speed of this blade or the particular windmill, and also what rate the acceleration is, and everything will be measured by using this MEMS acceleration sensor. Next is the motion sensors. So this will be motion sensor is something like it uses a sophisticated algorithm, and also it also uses the Zigbee wireless technology to so that it will exactly identify the motion capture of all the variations and the movement of the various processes. Okay, so noise cancelling or signal smoothing, and also to coordinate the system alteration. So if the process is equals to the non-linearity, then the motion control will indicate where it goes for the non-linearity, and then it also can able to recover the position of that particular thing. Okay, so this is mainly used in the automotive industry in ABS technology. Okay, and this application is numerous applications ranging from industry, entertainment, sports to education, that is triggering airbag deployments or monitoring of nuclear reactors. So triggering of this airbag deployment is nothing but mainly is related to the motions. Okay, so only after the impact of that particular vehicle the airbags will be released. So what is the impact, what is the impact speed should be there. Okay, so the particular pressure impaction will be considered, and then the airbags will be open. Also nuclear reactor. Okay, so the nuclear reactor it should be always in a contained fissionable reaction should be there. Okay, if uncontrolled, if it goes means then it will go to non-linearity. If the non-linearity happens in nuclear reactors, that is also danger. Same for the airbag deployment also. So used for measuring the static electricity, acceleration, gravity, and then dynamic acceleration and shock of and vibration. Cell phone, washing machine, and computers also the other applications. Okay, used to detect the motion. Next is the torque sensor. So torque sensor is essential for the mechanical stops or overload capacity during the mounting operation. So we need to mount that particular component, and then we need to switch on the process. Means the torque should be exactly same, so that it will be mainly considered in the CST, or that is the continuously stilled tank reactor, where the continuous stirring will happen, so that a particular torque should always be there for the mixing purpose or whatsoever. Okay, so rotating torque and the torque transfer for some of the few important sensors used in industrial automation. Okay, so it's used for measuring the reaction of rotating torque. Okay, rotating torque is some of the circular motion, and it is mainly used for the extra safety during the mounting and operation. And torque transducer, so they utilize a superior strain gauge. Okay, so strain gauge is nothing but the change in electrical resistance variation with the change in strain. So whenever there is a small change in the strain, small variations in the strain in a particular object is being expressed means that the strain gauge will be there. So this transducer will act as a superior strain gauge, and then it will be measuring the small strain variations, and it will be as an electrical signal as the output. An application used to measure the speed and rotation of maintenance and mass movement, and also used in the point of vision of a quasi state. That is a somewhat a low state process is called as a quasi state in mechanical engineering type of thing. And in that process also torque transducer is used to measure the highest speed of rotation of oscillating. And that's it. From today's class, I think we'll be able to understand the basics of the pressure sensor, temperature sensor, Mem sensor, and torque sensor, because these sensors plays a major role in the automation industry. Thank you. Thanks for listening.